The James Webb Space Telescope has just captured something so terrifying on 3I Atlas that scientists are calling it a total nightmare. What was thought to be a drifting interstellar rock has begun to move, pulse, and respond. Its surface glows like metal. Its energy rises in perfect rhythm, and its trajectory has just changed toward the solar plane. NASA is silent. Telescopes are locked on because whatever Atlas is, it's awake. The moment the alarm went off, it began quietly on July 1, 2025 at 3:47 UTC when the James Webb Space Telescope, JWST, received an automated priority alert from its Deep Field Observation queue. The target, catalogued as 3I, the third confirmed interstellar object ever detected, wasn't scheduled for study until late August. Yet its infrared profile had suddenly surged by nearly 18%, enough to trigger Webb's anomaly detection system. In routine astronomy, an alert like that usually signals a data calibration issue. But as the minutes passed, calibration wasn't the problem. Atlas was. 4:15 UTC, JWST's near-infrared spectrograph, an IR-spec, locked onto the object. What it recorded was unlike anything the mission team had seen since the telescope's launch in December 2021. The light wasn't flickering randomly as ice and dust evaporated under sunlight, as comets typically behave. Instead, the object's glow fluctuated with mathematical precision, brightening and fading in a repeating 4-hour cycle. This wasn't chaotic organic behavior, it was rhythmic. Something at the heart of Atlas was pulsing, emitting energy in intervals that matched no known natural process. At NASA's Goddard Space Flight Center in Maryland, scientists reran the data 3 times, searching for interference from solar reflections or cosmic rays. Each test produced the same result. The object's infrared emissions rose and fell like a beating heart. "It's clockwork," one analyst wrote in the mission log at 4:52 UTC. To verify the anomaly, control centers pinged observatories across the globe. ESO's Very Large Telescope in Chile, Keck observatories in Hawaii, and the Hubble Space Telescope itself all confirmed the same strange pulse pattern emanating from the coordinates of 3I Atlas. By sunrise on the U.S. East Coast, July 2, 2025, every major observatory on Earth had joined the monitoring effort. What began as a faint anomaly had become a coordinated international observation campaign. But even then, few realized the magnitude of what was unfolding. The first report spoke of an unusual rotational dynamic or periodic thermal activity. Yet one internal memo from the European Space Agency captured the tension best. This pattern suggests intent. In other words, the data hinted at control, an idea so alarming that mission leads flagged it as a psychological hazard term to prevent premature public release. The nightmare had begun quietly, and it was about to grow louder. As data streamed in from across the world, 3I Atlas's thermal pulse wasn't random noise. It was structured, consistent, and measurable. But to understand why scientists were panicking, one must first grasp what this object was supposed to be. It wasn't meant to glow, pulse, or move deliberately. It was supposed to be a rock, a frozen relic from another star system like Oumuamua in 2017 or 2I Borisov in 2019, and yet, from the first day of observation, Atlas refused to behave like either. When 3I Atlas was first discovered by the Asteroid Terrestrial Impact Last Alert System, Atlas on July 1, 2025, astronomers celebrated what they thought was a routine milestone. At an initial velocity of 61 kilometers per second, it was fast, far faster than any comet bound to our sun, but nothing out of the ordinary for an interstellar traveler. The excitement stemmed from its status, the third visitor from beyond our solar system, following Oumuamua in 2017 and 2I Borisov in 2019. Back then, scientists hoped Atlas would answer lingering questions those earlier visitors had raised. Instead, it posed new ones. Early brightness measurements from the Vera C. Rubin Observatory in Chile showed that Atlas was at least 3 times more reflective than expected for its estimated 5 to 7 kilometer diameter. Typically, that level of reflectivity indicates ice-rich composition, meaning a strong coma should form as the object nears the Sun. But even as it crossed the orbit of Jupiter on July 10, 2025, no tail appeared. The object was smooth, silent, and unnervingly stable. It didn't tumble or spin erratically like most comets. Instead, it rotated once every 6 hours, perfectly consistent like a machine. By mid-July, data from ESA's Gaia mission refined Atlas's trajectory, confirming it wasn't gravitationally captured. It was passing through. The shape of its path, a hyperbolic orbit with an eccentricity of 1.11, meant it entered from deep interstellar space and would soon exit forever. Yet in that brief time, its behavior defied every prediction. The lack of outgassing, the steady luminosity, and the absence of dust particles suggested the surface was metallic, not icy. These properties were confirmed by JWST's mid-infrared instrument, MIRI, which detected a signature closer to metal alloys than frozen volatiles. For planetary scientists, this was the moment things turned from strange to impossible. Every natural model failed to explain Atlas's light curve. Its temperature variations didn't correlate with solar distance, and its rotation showed no signs of wobble or degradation. "It's like a spacecraft conserving energy," wrote Dr. Lena Marovic of ESA's Exoplanet Division in an internal email dated July 16, 2025. The tone was half joking, but by then, jokes had begun to sound like warnings. By the third week of July 2025, scientists around the world had exhausted every conventional explanation for Atlas's behavior. It wasn't reflecting sunlight normally, wasn't shedding material, and wasn't slowing down as a natural comet should. That's when the James Webb Space Telescope aimed its most powerful sensors at the object, and what it saw would shake astrophysics to its core. Because in the cold void between Mars and Jupiter, something inside Atlas began to beat. The first strange reading came on July 18, 2025, at 3:56 UTC. The James Webb Space Telescope recorded its most haunting data stream to date. Using the mid-infrared instrument MIRI, scientists detected not a flicker or a burst, but a pattern. Every 4 hours and 2 minutes, 3I Atlas's thermal emission rose sharply, held steady for 23 minutes, then declined in a perfect mirror curve. This wasn't statistical noise. It was a heartbeat, a rhythmic surge of energy that repeated with mechanical precision. Natural comets don't pulse. They outgas irregularly, in chaotic bursts driven by sunlight. But this rhythm, consistent across 3 consecutive rotations, hinted at an internal process, one that was active, stable, and possibly deliberate. At NASA's Goddard Space Flight Center, lead thermal analyst Dr. Carrie Liss triple-checked the calibration. A glitch in MIRI's cryocooler could cause false pulses, but no anomalies appeared. Hubble's Wide Field Camera 3, observing an ultraviolet, confirmed brightness changes, synchronized within 2 seconds of Webb's infrared peaks. The European Southern Observatory's Very Large Telescope in Chile verified the same intervals at visible wavelengths. 4 independent observatories, separated by continents, detected the same thermal rise and fall, locked to the same timestamp. It wasn't coincidence. Something inside 3I Atlas was producing energy in timed cycles. When plotted against its orbital data, each pulse corresponded with a subtle micro-change in velocity, around 0.9 meters per second, as though each beat was exerting thrust. By July 19, 2025, the private research server at ESA's European Space Operations Center hosted an encrypted discussion titled Thermal Propulsion Hypothesis. One thread speculated that isotopic decay or piezoelectric fracture could explain the signal. Another countered that the pulse strength was too consistent. No natural isotopic mix could remain that stable over 48 hours. Then Dr. Lena Marovic, senior spectroscopist, posted a line that froze the forum. If it walks like a mechanism and breathes like a mechanism, maybe it is one. Within an hour, moderators archived the thread, and external researchers found their access restricted. Behind the digital walls, the debate had shifted from science to security. Across the Atlantic at Harvard's Center for Astrophysics, a small SETI sub-team reanalyzed the data using Fourier transforms. They found that the energy peaks followed not just a 4-hour rhythm, but embedded harmonics at 120 Hz, 180 Hz, and 240 Hz, frequency ratios common in engineered systems, not geology. That finding leaked to Reddit within days, spawning headlines like "Atlas has a pulse." By July 22nd, mainstream outlets caught up. NASA's press office released a single paragraph calling the data non-periodic thermal variability, a phrase that fooled no one.